Okay, when it comes to graphing logarithmic functions, it's often easy to think about it as an exponential and then kind of work backwards from that. So I'm going to first think about f of x equals 2 to the x in order to graph log base 2 of x. Okay, so if it was log base 3 of x, I would think about the table for 3 to the x. Or log base 10 of x, I would think about 10 to the x. So if I were to fill in this table for 2 to the x, again we would have here 1/8, 1/4, 1/2, 1, 2, 4, and 8. Again, plugging those in for the exponent for 2 to that power. So when you graph a logarithm and an exponential, those are inverse functions of each other. So what we end up with here is these x's and y's simply just switch location. And we end up with whatever y values we got for 2 to the x, those are now our x values here for log base 2 of x that make sense to plug into this to give us good answers like -3, -2, -1, 0, 1, 2, and 3. Okay, you can plug in a lot of different things into logarithms, just not 0 and not negatives, but you can plug in a lot of things here. But we want to figure out the nice things to plug in to give us good y values, and those are what we would see over here in this column for 2 to the x. Okay, so if we are graphing log base 2 of x, I'm going to always start here with this point, which is the point 1, 0. So all of our logarithms will go through that point 1, 0. Again, unless there's some kind of transformation going on, they will go through that, just like all exponentials go through the point 0, 1, unless there's a transformation. So we got this point 1, 0, and then we've got 2, 1, 4, 2, and 8, 3. And then as you get closer to 0, we're going to go down here in the negative. So at 1/2 we get -1, at 1/4 we get -2, and so forth. And what's going to happen is you are going to approach the y-axis, but never get to it. So it's never going to be 0, and it's never going to be negative. So the y-axis is acting as a vertical asymptote. So we have a vertical asymptote here at x equals 0, aka the y-axis. Okay, that's always the case with logarithms unless there again is a transformation where it's been shifted. Okay, so here we're looking at log base 2 of x. I already have this graphed. This is what I just graphed up here. We have that point 0, 1. We have that point 2, 1, 1, 0, and 2, 1. We have both of those graphed. Obviously, we have more like 4, 2. We already graphed that, and so forth. And I need to change this. This is supposed to be a 2, not a 3. So I want to graph these other functions that are just transformations of that. So if you just think about what the transformations are, it's often easy to start with the parent function and then apply the transformation. So that negative out front for number 1, that is a reflection over the x-axis. Right? That is an x-axis reflection. The negative on the inside is a y-axis reflection. And the transformations that we have on number 3, we have the -3 on the inside, that is going to the right 3 units. And then the plus -2 on the outside, that's not -2 times the log, it's just another way of saying -2 at the end without it being confused on if it's in the log or not. So we're just going to put it out front. So it's like plus -2. That is actually just moving it down 2. Okay. So I've graphed these in Desmos. It's just easier to do it that way. So the negative log base 2 of x. So log base 2 of x is the black function here. That's the initial one that we graphed. Negative log base 2 of x, that's our red one. That is the reflection over the x-axis. You can see that the black graph and the red graph are reflections of each other about the x-axis. Again, my vertical asymptote here is still the y-axis, or x equals 0. On the green function, that was the reflection about the y-axis. Again, check the black graph and the green one. They are reflections about the y-axis. Vertical asymptote, still for the green one, still x equals 0. It's just that our graph is on the other side of that now. And then the purple one is the one where we took right 3 and down 2. So if I take every point on this black graph and I go right 3 and down 2, I will end up on that purple graph, and I will get that entire graph. Now, that means, what is my asymptote for that purple graph? Well, it's dependent upon where you had your horizontal translation. So instead of it being at x equals 0, it's now at x equals 3 because we moved everything right 3, including the vertical asymptote. Okay. So what I would do if I were graphing these, I would pick those good points that we have, and I would just do those transformations with those points and graph those functions.